Okay, this is Math 131, section 1.3, and we're going to look at solving problems, generally looking at application problems or story problems. And we're going to start with what's called Polya's procedure, and this is named after George Polya, who was a mathematician who developed a procedure for solving problems. So we'll outline that first. Okay, so there's four basic steps to Polya's procedure. First, number one is understand the problem. Number two, devise a plan to solve the problem. Number three is carry out the plan. And number four is check the results. Now, you don't need to memorize these steps, but we'll kind of use these as guidelines when we do some of these problems. So we'll kind of refer to these as when we go look at the examples. Okay, so the first step, understanding the problem, that involves reading the problem carefully. Okay, at least twice. Okay. So read through the problem a couple times so we know exactly what's going on. Try to make a sketch, draw a diagram of the problem, label the information given. Important to kind of understand everything that's going on and what's being asked. Make a list of the given facts that are pertinent to the problem. See if you have sufficient information to solve. Okay, so that's important to look at. So basically trying to get an idea of what is being given and what's being asked. Okay, step two is come up with a plan. Is it similar to something we've done before? Okay, so can you relate this problem to a previous problem? Okay. Can you express the problem in terms of an algebraic equation? So can we come up with some sort of maybe a mathematical equation to relate it? Look for patterns or relationships. Okay. And can you express more simply? So express more simply. Maybe a way to simplify the way the problem is designed. Okay, continue with step two, devising a plan. Can you substitute a smaller or simpler numbers to make the problem more understandable? So think of way smaller or simpler numbers. Okay, listing information in a table. Okay, to help in solving. Educated guess at the solution. So that's a good idea just to make sure if your solution makes sense. Step three is just solving the problem. So basically, you got some equation or something to carry out the plan, some plan devised, and this would be step three, is just carrying out the plan, actually getting the solution. Step four is checking your results. So important to ask, does the answer make sense? Okay. Is it reasonable? Okay. If it's not reasonable, recheck your method. Okay. See what you did wrong, and check your calculations. Can you check the solution using the original statement? So answer your question in the original statement based on your answer and see if that makes sense. Okay. Maybe see if there's an alternative method to get the same conclusion. Can the results of this problem be used to solve other problems? So some of the questions you might want to ask, but basically we're going to make sure the result makes sense and then answer it in the context of the original question, kind of in words. Okay, so the first example we'll look at, we're looking at an airport shuttle service from San Antonio International Airport. And the shuttle is approximately 10 miles, the hotels are approximately 10 miles away. Okay, and one particular shuttle makes 16 round trips per day. So 16 round trips per day. Okay, and each carries 5 passengers per trip. Okay, and then the fare that they pay is $18 each way. And we want to know what are the receipts from one day's operation for this particular shuttle. So we're going to look at kind of ways to figure this out based using a mathematical model or mathematical equation. Okay. So we could start by listing the information. The distance from the airport to downtown hotels is about 10 miles. Number of round trips per day is 16. Number of passengers per trip is 5, and the fare each way is $18. Okay, so really that's we're kind of compiling information there and putting it in a list. Okay, so getting our solution, the round trip costs $36. 2 times 18, so it's $18 each way, and then the total receipts for one day is the product, okay, of number of round trips. Okay, so that's 16. Times the number of passengers, which is 5. And then the cost per round trip, which is 2 times 18, so times 36. And if we multiply those using mental math, we could say 16 times 5, I'm doing this mentally, but 16 times 5 is 80, okay? And then we're going to go 80 times 36. Now, we could say, in this case, 8 times 3 is 24, right? So 80 times 30 is 2400. And then the other part would be 8 times 6 is 48, but 80 times 6 would be 480. So our partial products would be 2400 plus 480. That's how we get the 2880. So we can actually do this mentally. You could use a calculator here, but just showing you how we could do this using mental math. Okay. So that would be the total receipts for the day based on 16 round trips, okay, 5 passengers per round trip, $36 they pay for each round trip. Okay, we're multiplying. Okay, our next example, we're talking about planning for retirement. So U.S. Census Bureau data indicates that at age 65, the average woman will live another 21 years, and the average man will live another 19 years. So age 65, the average woman will live another 21 years, and the average man will live another 19 years. So, once you reach age 65, as a woman, you can expect to live to about 86. As a man, you can expect to live to about 84. Okay. And then the data also indicates that about 33% of the average person's retirement income will come from Social Security. Okay. So that covers a third of your income. Now, we call, retirement a three-legged stool. And we can say Social Security is one of those legs. So it's not going to, sustain you in your retirement completely, but it's about a third. Okay, so the next graph that we're going to look at shows how long a typical retiree's assets will last based on the percentage of the assets withdrawn each year. So we look at how much percent that we take out each year, and that tells us how long it will last. Okay. So just to explain here, if you take 10% of your retirement out every year, you expect your money to last 11 years. Okay. Now, it doesn't last 10 years because the money that stays in there is earning interest. So that's why it's a little bit more than 10. You could say, well, it shouldn't be 10% because you're taking 10% out, 10 years because you're taking 10% out every year. Yes, if you didn't earn interest, but because you're earning interest on the money that's still in there, it's going to last a little longer. If you take out 9% every year, then you have 13 years to take the money out. 8%, you have 15. 7%, you have 18 years. 6%, you have 21. 5%, you have 27. If you take 4%, you have 33 years. So this is what you do, what financial advisors will do when you're looking at retirement planning is look at how many expected years you have left of life at age 65 based on census data, and then figure out what percent you would need to take out annually of your assets to to last that many years, and then figure out what your income needs to be per year to figure out, 4%. Let's say I can only take 5% out, which is 1/20th. Then I have to make sure I have enough money so that when I take out that 1/20th every year, it's enough for me to live on, including Social Security, etc. Okay, so if a typical retiree has retirement assets of $500,000, okay, how much can he or she withdraw annually if he or she wishes the assets to last 21 years? So if you want the money to last for 21 years, how much can you take out? Okay. So we go back to our table and we look at 21 years, okay, because that's how long we want our money to last. And that says we can take out 6%. Okay, so we're going to take out 6% of our money every year, and that will give us the 21 years that we need. Okay, so from the graph, for assets to last 21 years, about 6% of the assets can be withdrawn annually. Okay, Okay, so amount is 6% of assets. Now we do 6%, we're going to do 0.06. That's the decimal version of 6%. That's, we can say that 6% is not a real number. We have to write it as 0.06. And what we do is divide by 100 to get that. So we take 6 divided by 100, we get 0.06. So 6% of 500,000 would be 6.06 times 500,000, which we can do this mentally, but that's $30,000. Okay, so that if you were the retirement advisor, say, yeah, well, you can take out about $30,000 a year from your retirement. Okay. So let's look at a different scenario. Let's say you wish to withdraw $25,000 annually, and you want assets to last 18 years. So we would go back to our graph, but we're going to do a little bit different thing. We're going to look at the percent, or we're going to look at how much in assets you would need. Okay, so we have 18 years, okay, and what do we want? We want $25,000, and that's going to be 7% of whatever we have saved up. So we're going to say 7% of what we have saved up is we want to make to be $25,000. Okay, so from the graph, for assets to last 18 years, about 7% of the assets can be withdrawn annually. Okay, so we saw that. Okay, and that amount has to equal $25,000. So this one's a little bit different because we're going to say we don't know what the assets are, but we're going to say 7% of assets is $25,000. That'll be the amount we can take out every year. So 0.07, again, 7% is a decimal, times assets equals $25,000. Okay, and we're trying to solve for assets. So we're going to take 25,000. Now what we're doing is we're dividing both sides by 0.07, and I'll kind of write that in here. So if we take this and divide by 0.07, see, it becomes assets there, and we divide this by 0.07 too. Okay, so that's how we get this. Assets equals 25,000 divided by 0.07. And we'd use a calculator for this, but we would need about $357,143 in order to do that, in order to take $25,000 out annually for 18 years. Okay, but we're using that graph, but just doing it a different way because we don't know what the assets need to be. And when you're doing retirement planning, you need to know that. You need to know how much you need to have when you retire at 65. Okay, now we're looking at how do we determine a tip. We looked at something similar to this in section 1-2, but the cost of Freddie's meal before tax is $28. Okay, so that's the total bill. Okay, haven't added tax yet. We add a 6.5% sales tax is added, so we need to do that. Then we need to determine the total cost of the meal, including the tax. Okay, so remember for percent, 6.5% is going to be a decimal. That's 0.065. Okay, so 6.5% we have to write as a decimal number, 0.065, in order to use a calculation for that. Okay, so the first thing we do is change 6.5% to a decimal, 0.065. That should be 6.5% there. So sales tax is 6.5% of meal. So our actual tax we pay is 0.065 times the bill, which is $28. Okay, so that gives us $1.82 in sales tax. Okay, so total bill is cost of meal plus sales tax. So total bill is 28 plus 182, which is 29.82. Okay, and the bill including sales tax is 29.82. Okay, now let's go back to the meal before tax. Okay, he wants to leave a 10% tip on the pre-tax cost of the meal first. Okay, so how much should he leave? Well, remember we did this in class, but it's pretty easy, right? You just take 1/10 of this, or what you can do is just move the decimal over here, and that would be 280, right? So the 10%, he's a cheap tipper, would be $2.80 on the pre-tax cost of the meal. That would be like, I'm leaving the absolute minimum tip I'll ever leave because the service was horrible. right? Because you're not even leaving 15%, you're leaving 10%, and it's on the pre-tax cost. Most people don't do that. So, okay, so to find 10% of any number, multiply by 0.1. Okay, in other words, we're just moving the decimal over by 1 to the left. Okay, so 0.1 times 28, 10%, is 280. And again, we're just moving that decimal from here to there. Okay, we divide by 10. Okay. So to find 10% of a number is to move the decimal point in the number one place to the left. So again, we go from 28 to 280. Okay, let's say he wants to do 15%, okay, on the pre-tax cost, okay. 15% tip on the pre-tax cost. So how much should he leave? So we're going to use that 28 because we're talking about the pre-tax. Now remember we talked about this in class. To find 15%, find 10% and then add to it half of that amount, okay? Because 10% is 15% is 10% plus 5%, which would be half of that 10%. So we can add that 280 that we already figured, and then add, that would be the 10%, and then we can add the 280 divided by 2, which is the 5%, so that would give us 15%. So it'd be 280 plus 140, which would give us 420 total. So we can do this mentally, right? Once we have this down, 280 plus 140 is 420. That would be 15% based on the pre-tax amount of $28. Now, if we wanted to do it on the total bill, we would have to use that 2980, whatever our bill was, and take 10% of that, and then another half of the 10% to get 15%. So, and generally when you tip, you should tip on the total bill, not on the pre-tax bill. Okay, let's look at an example of a brine solution for smoking turkey. Okay, they recommend for smoking turkey, recommend pre-soaking the turkey in a brine solution, which is like a liquid that's kind of salty, might have stuff in it. Okay, so to smoke a 12-pound turkey, use 16 tablespoons of salt in 2 gallons of water. So there's our brine solution. Okay. Let's say we only want to make 3.5 gallons of a brine solution. So we don't want or we want to make more, right? We don't want 2 gallons, we want 3.5, okay? So we want to use 60 tablespoons of salt for 2 gallons. How much do we want to use for 3.5 gallons? We're doing a bigger turkey, right? More than 12 pounds. Okay, so what we want to do here is look at the ratio and set up what we call proportions. So the given ratio, okay, is 16 tablespoons for 2 gallons, okay? And we want to use 3.5 gallons. So what we do is we set up another fraction and set it equal, and we're going to have 3.5 gallons on the bottom, and we don't know how many tablespoons on the top, and that's what we're trying to figure out. So this is our item to be found, is that how many tablespoons of salt for 3.5 gallons. Okay, so this fraction is called a ratio. Tablespoons in 2 gallons, 16 tablespoons in 2 gallons, and and this is our other ratio. How many tablespoons in 3.5 gallons? Make sure you have your gallons in the same part of the fraction on each side. So we have gallons here, and tablespoons on the top on each side. This is called a proportion. Okay, we set two ratios equal. And to solve this, what we can do is we can cross multiply. So we can say this times this, 16 times 3.5 equals 2 times x, or we don't know what that is. So when you have a proportion where you have a fraction equal to a fraction, we can cross multiply to solve that. Okay, and that's when we say we have a proportion, we can do that because that's a fraction equal to a fraction. Okay, so here's our proportion. 16 over 2 equals x over 3.5. We just didn't write the units down. And here's the cross multiplying. 16 times 3.5 equals 2 times x. So 2x means 2 times x. Do you see why we're not using x for multiplication anymore? We're not using for times, we're just using dot, or sometimes we can just put the things next to each other. So x is our variable. That's why. It's because we're using x as a variable. 2x means 2 times x. Okay, so 16 times 3.5 is 56. Okay. mental math, 16 times 3 is 48, and then 16 times a half is 8, and 48 plus 8 is 56. Okay. And then 2 times x is 2x. Okay. And then we divide both sides by 2 here to get 28 equals x. Okay. So we would need how many tablespoons of salt? 28 tablespoons of salt to make 3.5 gallons of that brine solution. And our turkey is, is bigger than 12, right? Okay, the second part of this example is you wish to make enough brine solution to soak a 20-pound turkey, and you know how much salt is needed. Okay. So now we want a bigger turkey, and we don't know how much solution we need to make. Okay, now we can set up a proportion using how much salt based on how many pounds of turkey. So we're not looking at the water here. We can do that as well, but we say for 12-pound turkey, your brine solution is going to have 16 tablespoons of salt. So for a 20-pound turkey, how much salt is there? Okay, so we have 12 pounds over 16 tablespoons as one ratio equals 20 pounds for our other turkey over how many tablespoons for our other ratio. So this proportion is 12 over 16 equals 20 over x. Okay, so there's our proportion. 12 over 16 equals 20 over x. Cross multiply. 12 times x equals 16 times 20. Okay. Or 12x equals 16 times 20 is 16 times 2 times 10, so is 320. So 12x is 320. Divide both sides by 12, and we get x is 26.67. So we need about 26.67 tablespoons of salt to make enough brine for a 20-pound turkey. Now, a couple things. First of all, we could round that to 27. Okay. We could maybe even round to 28. And the reason we might do that is think of this. A tablespoon, there's 4 tablespoons in a quarter cup, or there's 16 tablespoons in a cup. So let's say you didn't want to have to measure, 27 tablespoons. Well, every 4 tablespoons is a quarter cup. So you could just use a quarter cup of salt 7 times to get 28 tablespoons, right? Or you could take a full cup and then add a quarter, so that would give us 5 quarters. Or sorry, we want 7, don't we? So you would take, how many? You would take 1 3/4 of a cup of salt. That's going to give us 7 quarter cups, which would give us 7 times 4 is 28 tablespoons. Okay, so that's another way to look at that is, you could say, well, I know that there's 4 tablespoons in a quarter cup. Okay, and then every quarter cup will give me 4 tablespoons. So that way I don't have to scoop that thing out 27 or 28 times. Okay.